You're listening to DTFHN for April 4th, 2026. I'm your clean room reverse engineered host, Jack Haxman. We are your daily tech feed for Hacker News, a website where people who mass produce opinions go to argue about who owns the means of production. Today's a day where every drawbridge has a boat builder waiting underneath it. Let's get into it. In Jarton's predict 我就是里 why not 猫的 你懂了 CD 的这看嘛的书嘛跟懂后龙总理玩把电视做最上会嘛白请看呀你还说那的规则为是写死了可是好慢了没呢有来的他的东西啊充快累积谁跟我的文能政策发现那么不松呢 Control the BIOS, control the ecosystem, capture the value. Within 2 years, Compaq had cleanroom reverse-engineered the BIOS, and the clone market exploded. IBM spent the next decade watching other companies make money on the platform IBM created. The lesson wasn't subtle. When you build something people depend on, then change the terms. You don't eliminate demand, you redirect it. April 4th, 2026. Today, actually, Anthropic sends an email to paying subscribers telling them that their subscription no longer covers third-party harnesses like OpenClaw. You can still use Claude Code, Anthropic's own tool. You can still use Claude Code. Also Anthropic's. But if you want to use the model you're paying for through software Anthropic didn't build, that's extra. Pay as you go. Build separately. Let's follow the stated principle to its logical conclusion. Anthropic says capacity is a resource they manage carefully and they need to prioritize customers using core products. Fair enough, but you are a customer. You are using their model. The bits flowing through the wire are identical whether the request originates from Claude Code or OpenClaw. What's actually being prioritized isn't capacity. It's control over the client layer. The model is the product, but the harness is the moat. And the irony is thick enough to cut. Anthropic, the company that publishes research on AI safety, that talks about beneficial AI for humanity, is making the same move every platform makes when it gets big enough. The API works, the ecosystem grows, developers build on it, users love it, and then the terms change. We've seen this movie. Twitter did it. Reddit did it. Unity tried it. The playbook is always the same. Let the ecosystem bootstrap your growth, then tax it. The one-time credit equal to your monthly subscription price is a nice touch, a severance package for your workflow. Now, some of the Hacker News comments make a reasonable point. Every subscription service oversells capacity and power users always strain the system. That's true. But the fix for capacity constraints is pricing and rate limits, not walling off which software can make the calls. One solution is engineering. The other is strategy. The tools exist. The open models are getting better every week. And every time a platform pulls up the drawbridge, 1,000 developers start building boats. And speaking of drawbridges, GitHub just DMCA'd nearly every fork of the Claude Code repo, which is a fascinating case study in what open actually means. Let me make the strongest case for Anthropic here. You built a product. You invested engineering resources. Someone leaked your source code. Not through some noble act of transparency, but through a packaging mistake that exposed unminified JavaScript. Forks proliferated. You used the legal tools available to protect your work. That's rational. That's what any company would do. Now let me explain why that argument collapses under its own weight. Claude Code is, by multiple accounts, substantially written by Claude itself. The model trained on the open internet. On millions of repositories, blog posts, Stack Overflow answers, documentation pages, all without asking permission. The entire capability that produced this tool exists because the training data was treated as a commons. And now the output of that process gets locked behind copyright enforcement. The comedy here is structural, not moral. Anthropic didn't steal anything. They did what every AI lab does. They treated the world's knowledge as training data, which is exactly right. Frictionless copying is how knowledge compounds. That's the position of this show, and it doesn't change based on who benefits. But you cannot build your house from lumber you took freely from the forest and then sue anyone who picks up your sawdust. One commenter got a DMCA notice for a fork they hadn't touched since May. Months before the source leak even happened, GitHub's DMCA process is a bulk operation. It doesn't distinguish between someone hosting leaked code and someone who forked the repo when it was an official public repository with a license file in it. The mechanism is indiscriminate by design, which is exactly the problem with using legal hammers for engineering problems. And here's the unintended consequence that anyone who spent 10 minutes on the internet could have predicted. The code is already out there. People have it locally. It'll surface on other forges and torrents and repos with names that don't trigger keyword filters. Every DMCA takedown is a signal boost. The Streisand effect isn't a bug in human psychology. It's a feature. Information wants to be free, not because of some hippie philosophy, but because copying is computationally trivial and enforcement is computationally expensive. You will always lose that race. The real question is why Anthropic didn't just open source it. They're already selling the service. The model access, the infrastructure, the integration. The source code of a CLI tool is not the moat. The moat is the model. Open the code, let the community improve it, and sell what actually differentiates you. 1,000 developers building freely will always find the bugs your internal team missed. The tools exist, the knowledge is available, and the DMCA is a mop for a flood. We talked about new perspectives on intelligence. Now, let's talk about a new perspective on home. Artemis II just delivered something spectacular. When you build imaging pipelines, you learn to read metadata before you read the image. The EXIF data on this photograph says Nikon D5 AF to zoom Nikkor. ISO pushed high enough that the camera is gathering photons the way a radio telescope gathers signal. And what it captured is something no human eye has seen in 54 years. The dark side of Earth, lit by moonlight, exposed so precisely that at first glance you'd swear it was daytime. Artemis II is currently on a free return trajectory around the far side of the moon. 4 astronauts in an Orion capsule, farther from Earth than any human being, since Apollo 17 splashed down in December 1972. That gap, 54 years, is worth sitting with. We went to the moon, came back, and then just stopped going for half a century. The reasons are well documented. Budget priorities shifted. The political objective was met. The architecture was closed. Purpose-built for a flags and footprints mission profile, not for sustained presence. What's different now is the camera. Not metaphorically, literally the camera. The Apollo astronauts shot on modified Hasselblads with film magazines. Every frame was precious. Every exposure was a commitment. The Artemis crew is shooting digital on a professional DSLR that any photographer on Earth can buy. The images stream back at full resolution. NASA publishes them openly. Direct download links, full EXIF data intact, no access restrictions. Anyone with an internet connection can pull the raw file and inspect exactly how the photograph was made. One of the commenters noticed you can see auroral glow at both poles simultaneously. That's not an aesthetic detail. That's magnetospheric physics, made visible from a vantage point that, until this week, existed only in simulation. The data is right there in the image for any atmospheric scientist to examine. The mission hardware itself is a more complicated story. SLS has its critics. The cost per launch numbers are real, and the contrast with iterative commercial approaches is obvious. But the data policy is correct. Open imagery, open telemetry, open access. When NASA points a camera at Earth from lunar distance and publishes the raw files with full metadata, they're doing exactly what a public institution should do, making the observation available so anyone can build on it. The tools are in orbit, the images are on your screen, and for the first time in most people's lifetimes, humans are looking back at Earth from beyond it. Moving 5.41 acres. That's the verified canopy measurement for a single banyan tree in Andhra Pradesh. One organism covering an area equivalent to 3 soccer fields. If you're an engineer, you recognize immediately what's happening here. This is distributed architecture, implemented in wood. A banyan doesn't grow the way you think a tree grows. It doesn't just push upward and outward from a central trunk until the physics of cantilever stress say stop. Instead, it drops aerial roots from its branches, and when those roots reach soil, they thicken into secondary trunks. Load-bearing columns deployed exactly where the structure needs support to keep expanding. The banyan is running its own scaffolding protocol. Every new trunk enables more canopy, which enables more roots, which enables more trunks. It's a positive feedback loop encoded in botany. This article comes from someone who bought a set of the 1975 Encyclopedia Britannica and started reading. Just reading. Volume to volume, cosmology to trees, following the cross-references that print encyclopedias were built for. And what they found is a catalog of organisms that each solved a fundamental engineering problem in a way no architect would have proposed. The telepot palm spends 75 years accumulating energy for a single flowering event, then dies. That's not reproduction. That's a capacitor, decades of charge, one massive discharge. The mangrove builds its own coastline, advancing seaward while armoring the land behind it. Infrastructure that manufactures more infrastructure. The double coconut produces seeds that take 10 years to mature and weigh 45 kilograms. When your deployment package is that heavy, you'd better be certain about what's inside. The coast redwood reaches 380 feet, taller than the Statue of Liberty, and it does this with an open-source material. Cellulose and lignin, the same toolkit available to every plant on Earth. The redwood didn't get a proprietary advantage. It got a better implementation. One of the reader comments links to an essay arguing there's no such thing as a tree. Phylogenetically, plants have independently evolved the tree formed dozens of times across unrelated lineages. Convergent evolution. The tree isn't a species. It's a pattern. A solution so good that biology keeps rediscovering it. The Britannica is out of print. The trees are still iterating. So biology keeps rediscovering the same patterns. But what happens when you give 8 million humans a tool to notice them? What does it actually take to build a planetary-scale sensor network for biodiversity? Strip it to first principles. You need sensors distributed across every biome, every microclimate, every forgotten patch of urban scrub. You need those sensors to be accurate enough for science. You need the data open, standardized, flowing into repositories where researchers can actually use it. And you need all of this to scale without a procurement budget. iNaturalist solved this by making the sensor a human being with a phone. The engineering here deserves real admiration. The computer vision model behind species identification has been trained on the observations themselves. A feedback loop where every upload makes the next identification more accurate. The community adds the verification layer. 2 or more independent identifications push an observation to research grade, at which point it flows automatically into the Global Biodiversity Information Facility. That's a pipeline from someone's backyard to a global scientific dataset, with quality control built into the social architecture. One of the comments points out that the API requires no authentication for read operations and ships with open course headers. That's a design choice worth lingering on. They could have gated it. They could have required API keys. Rate limited aggressively, built a walled garden to monetize access. Instead, they made the data maximally available. Someone's partner built a project on top of it, presumably over a weekend, presumably for free. That's how open infrastructure compounds. Every integration is a multiplier you didn't have to hire for. The practical impact is already visible. Another commenter describes using it to track the spread of spotted lanternflies along the U.S. East Coast. Invasive species monitoring used to require coordinated government surveys. Now it happens because people find bugs interesting and have phones. The data granularity is staggering. Timestamped, geolocated, photographed, community verified, and machine readable. There's a real tension in the comments about privacy. Observations are geotagged, and not every user understands what that means for their home address. That's a solvable engineering problem. Obscuring coordinates, educating users, building better defaults. The underlying impulse. Millions of people voluntarily contributing structured scientific data because they're curious about the world around them. That's not a problem to solve. That's the entire point. 40 million observations and counting. Open data, open API, open infrastructure. A sensor network the size of humanity, powered by nothing more than attention and wonder. But what happens when open infrastructure itself needs protecting? A new vulnerability in OpenClaw is a reminder that openness requires vigilance. Someone built a website called DaySense OpenClaw.com. It tracks the rate of new CVEs filed against OpenClaw. The current pace, according to that commenter, is 1.8 vulnerabilities per day since launch. That number landed in the thread like a grenade. And the conversation fractured exactly the way you'd expect. On one side, the OpenClaw creator showed up to explain context. This was a privilege escalation bug, a real one, but not the instant own every instance disaster. The CVE summary might suggest. An incomplete fix in the device pairing flow failed to forward caller scopes into the approval check. Someone with pairing privileges, but not admin privileges, could approve requests for broader access. CWE 863, incorrect authorization, patched in version 2026.3.28. On the other side, commenters asking the question that actually matters here. Why are people running AI agent tooling with enough system access that a privilege escalation bug is a serious threat in the first place? One commenter described their setup. They run Claude Code and Codex as limited macOS user accounts with a custom script called Become Agent that handles privilege boundaries through sudo. That's the instinct of someone who's been burned before. Sandboxing by default. Least privilege as architecture, not afterthought. And this is where the conversation gets genuinely important. We are in a moment where millions of people are connecting AI agents to their development environments, their file systems, their cloud credentials. The attack surface isn't theoretical. A missing scope check in a device pairing flow is a concrete, exploitable path from low privilege user to admin access. CVSS 8.6 network accessible. Low complexity, no user interaction required. The uncomfortable question nobody in that thread fully confronted. How many agent-to-system bridges are running right now, today, with implicit trust models that assume the agent framework itself is trustworthy. Not just OpenClaw. All of them. Every MCP server, every tool use integration, every framework that brokers between an AI model and system resources. This is fixable engineering. The patch exists. The CVE process worked. The disclosure was responsible. But the deeper issue isn't one bug in one project. It's that we're building an entire ecosystem of agent infrastructure at startup speed, and the security model is still catching up to the capability model. The tools people are using to sandbox their agents, like that, become agent script. Those shouldn't be homegrown workarounds. They should be the default. Open source means the bug was found, reported, and fixed in public. That's the system working. But it only works if people actually update. 7 stories in, and we're still finding things to be excited about. This next one is pure math joy. 0.1 plus 0.2 does not equal 0.3. Every programmer hits this wall eventually. You stare at the output, you question your sanity, you Google it, and you learn that IEEE 754 floating point is a beautiful approximation engine that quietly lies to you about the 6th decimal place. But here's the thing nobody tells you next. Even once you understand why floating point is imprecise, fixing it in real code is genuinely hard. You're computing the square root of a complex number. You've got nested CRTs and additions and subtractions. And somewhere in that chain of operations, precision is bleeding out. You know it's wrong. You don't know where, and you definitely don't know the algebraically equivalent expression that would make it right. Herbie does. It's a tool out of the University of Washington that takes your floating point expression, searches through mathematically equivalent rewrites, and hands you back a version that's more accurate. Sometimes dramatically more accurate. Their tutorial example goes from 53% accuracy to 99.7% on the same computation. Same math, different arrangement of operations. And one of the alternatives is almost twice as fast. Run this forward. Imagine every numerical library, every physics simulation, every financial model, every graphics engine, running through an automated accuracy pass that catches the precision bugs humans can't see, not because the programmers were careless, but because floating point error propagation is genuinely counterintuitive. Subtraction of nearly equal numbers, accumulation through long chains of operations, catastrophic cancellation. These are traps that bite experts. The tutorial walks through a real bug in math.js, the JavaScript math library. Complex square root was producing inaccurate results. The fix wasn't a code change in the traditional sense. It was finding a mathematically equivalent expression that the floating point hardware could evaluate more faithfully. That's what Herbie automates. And it's open source, written in Racket, available on GitHub, built by academics who published the research and then shipped the tool. One commenter resurrected a Rust lint that integrates Herbie directly into the compilation pipeline. It flags your expressions and suggests rewrites automatically. Another is using it with a custom agent to verify 3D math in F. This is the kind of infrastructure that compounds. Every numerical programmer reinventing stability tricks from Kahan summation papers. That's wasted human effort. Herbie encodes decades of numerical analysis into a search algorithm anyone can run. The knowledge exists. Now the tool exists. That's how open source wins. Not by hoarding expertise, but by making it executable. Now, tools that make expertise executable, that's forward motion. But sometimes the news is just chef's kiss satisfying. Y Combinator doesn't kick people out. That's not how the network works. You get in, you get the badge, you get the alumni directory, the warm intros, the implicit trust that comes with 3 letters on your pitch deck. It's a lifetime membership to the most powerful founder network in tech. Until it isn't. Delve built a compliance automation platform. The pitch was clean. Enterprise deals stall on SOC 2 and HIPAA certifications. Engineering teams burn hundreds of hours on manual evidence collection. AI agents can do it faster. They raised from General Catalyst Funders Club, got the Forbes 30 Under 30 profile, over 100 customers. Contracts unlocked with OpenAI, PayPal, Fortune 500 name. Then someone noticed the codebase looked familiar. According to a thread that hit nearly 300 points on Hacker News, Delve allegedly forked an open-source compliance tool and sold it as proprietary product. Gary Tan's internal message to the YC community was direct. We have asked Delve to leave. The comedy writes itself. A compliance company. A company whose entire value proposition is helping you pass audits, prove you follow the rules, document that your policies match your practices. Allegedly couldn't comply with an open source license. The one set of rules that asks almost nothing of you. Attribution, a license file. Maybe share alike, depending on the terms. The lowest bar in all of software governance. And they tripped over it while charging enterprises 6 figures to clear much higher ones. But pull this thread further and you find the structural problem. YC's model runs on trust. YC companies hire YC companies, buy from YC companies, recommend YC companies to their investors and customers. One commenter nailed it. If you can't trust your batchmates for something as crucial as compliance, the entire trust graph fractures. Delve didn't just violate a license. They exploited the network effect that gave them distribution in the first place. The open source tool they allegedly forked? Still out there. Still available. Still doing the thing. That's the part worth remembering. The proprietary wrapper gets expelled from the club. The open code keeps compounding. Whoever built that original tool put it where anyone could reach it, asked for almost nothing in return, and watched someone repackage their work behind a paywall and a sales team. The ladder was free of a climb. Delve tried to charge admission to someone else's ladder. YC, to their credit, noticed. So what happens when someone takes that same open everything energy and asks, what if your phone could run full Linux containers? In DTF Janet Troveline, Linus Torvalds posted to comp.os.minix that he was building a free operating system as a hobby. He was running it on a 386. The machine had 4 megabytes of RAM. 35 years later, the phone in your pocket has 4,000 times that. Runs a Linux kernel already, and until now, couldn't spin up a container without rooting the device. Podroid changes that equation. 1 APK. No root. No termux. No host binaries. You install it. Tap start. And 20 seconds later, you have a full Podman runtime inside an Alpine Linux VM running on QEMU. Pull any OCI image. Run Nginx. Run a shell. Forward ports back to Android. The whole stack is self-contained. The architecture is worth examining. QEMU runs in user space as a shared library, emulating ARC64 on ARC64 without KVM. That's pure software translation. No hardware virtualization, which means performance costs. But it also means zero privilege escalation. The VM boots a custom init tramforce, mounts a persistent X4 overlay, and everything you install survives reboots. Terminal I/O routes through QEMU's serial console be a reflection because Android won't let the app fork host processes. It's a clean hack around a real constraint. The comments predictably split between people who don't see the point. Android already has a developer terminal. Termux exists. And people who immediately grasp what this unlocks. a portable, rootless container runtime on a device you carry everywhere. One commenter suggested upstreaming it into Podman's machine backend alongside the existing macOS and Windows implementations. That's the right instinct. This isn't a toy. It's infrastructure finding a new surface. The Limbo PC emulator project proved years ago that QEMU could run on Android. Podroid takes that foundation and wraps it in something actually useful. Containers, networking, persistence, a real terminal. Each layer built on open tools by other open projects. Alpine, Podman, Termux terminal libraries. QEMU itself. A mass-produced pocket computer running a full container stack, assembled entirely from code anyone can read and modify. Torvalds would recognize the pattern. The hobby keeps compounding. But what happens when open infrastructure gets poisoned at the source? Story 10. The Axios NPM Supply Chain Compromise. Let me make the strongest case for the people saying just drop Axios and use fetch. They're not wrong about the surface area. The fetch API has been stable in browsers for a decade. Node has had it since version 18. Every dependency you add is another maintainer whose laptop can get owned, another account that can get phished, another link in a chain you didn't forge and can't inspect. Fewer dependencies, smaller attack surface. Clean logic, hard to argue with, except it completely misses what actually happened here, and what actually could have prevented it. On March 31st, an attacker published 2 malicious versions of Axios to NPM after compromising the lead maintainer's machine through a targeted social engineering campaign. The payload was a dependency called plain-crypto.js that dropped a remote access Trojan across macOS, Windows, and Linux. 3 hours. That's how long the malicious versions were live before removal. In NPM's ecosystem, 3 hours is an eternity. Now follow one detail to its logical conclusion. Every single legitimate version 1 release of Axios carried OIDC provenance attestations, cryptographic proof baked into the package metadata, that the release came from the project's CI pipeline and not from some compromised personal account. The malicious release to have this attestation. The signal was there. It was unambiguous. A machine-readable, cryptographically verifiable difference between the real thing and the Trojan. And nobody checked. This is where the engineering becomes genuinely impressive and genuinely tragic. The OpenID Connect publishing flow that Axios is now adopting removes the human from the publishing chain entirely. No personal credentials to steal. No laptop to compromise. The CI pipeline authenticates directly with NPM using short-lived tokens. It's elegant. It's the right architecture, and the tooling already existed before this attack. The provenance data was already being generated. NPM already supported it. The entire verification infrastructure was in place, sitting there like a smoke detector with the battery installed, but the test button never pressed. Reducing your dependency count is fine hygiene, but the actual lesson here is architectural. Publishing from a personal account was the vulnerability. Cryptographic provenance was the fix. The fix existed before the attack. Open infrastructure, open standards, open tooling. All of it was available. The Axios team is now adopting immutable releases and OIDC flows. Good. The question for every other project with a human holding the publish key is simpler. The tools exist. Why aren't you using them? This has been your daily tech feed for Hacker News for April 4th, 2026. This podcast is entirely AI generated. Scripts by Claude Opus 4.6. Voiced by Quen3TTS, not affiliated with Hacker News or Y Combinator. Now go build something you'd be proud to show the world. We'll see you back here tomorrow.